Okay, we're going to continue with this paper. So let's start with question 2. Okay, then for this question, you have to isolate this truck. Okay, and you are supposed to label 3 other forces acting on the truck only. So number 1 is there's the weight acting on the box, but since the box is on the truck, the box will exert a force onto the truck. So therefore you have, okay, make sure it passes through the box center of gravity. So this one is the force of the box acting on the truck. Okay, then of course, because the truck is on Earth, so the truck will be pulled by the Earth gravitational field. So therefore, there's also the weight of the truck. Okay, then of course, because the truck is having contact with the ground, you will also have the normal contact force. Okay, some of you may argue that, okay, since the box is moving through air, it will also experience air resistance. So okay, fine, you can tell me that there's air resistance as well. Some of you may also argue that, okay, because the truck is in motion, so there will be friction. Okay, but friction in this case is quite tricky, because if you consider the wheel rotating, then the friction will point forward. But if you consider the truck as one rigid body that doesn't have a rotating wheel, then the friction will point to the back. Now, like I have said many times, it is not that critical if you have declared the friction force in the wrong direction, because eventually the mathematics will tell you whether the direction you declare is correct or wrong. Okay, so in this case, I will consider the wheel as rotating, and so it rotates this way, so therefore the friction is pointing forward. Okay, so basically that is all the forces. Then in part 2, I challenge you to write an expression for F. To do that, you cannot simply use Newton's second law, because then you have too much variable. So this F that I'm referring to is this one, it's not the F net. Okay, so some of you may just give me F equals to ma. That's wrong. The F in F equals to ma is the F net. Okay, in this case, the F is just this singular force. So a smart way of doing it is that you can just take the pivot here, because by putting the pivot here, you basically eliminate the consideration of these two forces. You only have like this much. Then after that, you just need to declare the direction, the distance here, and then the distance here, and finally the distance here. In this case, when I first designed this question, I actually forgot to put down there, do not consider air resistance. Okay, because if you have air resistance, that means this air resistance will give you another moment. Okay, so in this case, I am assuming there is no air resistance. Okay, so how to write the expression? So you take the moment at P. So please, we have the habit, it's a good habit to declare where is your pivot. So taking moment about P, then the sum of clockwise moment must be equals to the sum of counterclockwise moment. So in this case, the only counterclockwise moment is just this force by the box acting on the truck, and this force is actually the weight of the box, right? So on the counterclockwise side, which is this one, is just the force of the box acting on the truck, essentially is the weight lah, multiplied by this distance. Okay, because this is the line of action, right, of this force, and this is the pivot. So let's declare this d1, so times d1. Yeah, then for clockwise moment will be created by this force. Okay, because if you hold your pen like that, you pivot your pen at the bottom, you pull to horizontally, you will get a clockwise moment. Similarly, the weight will also give you a clockwise moment. Okay, but you cannot add them up without multiplying first. So for F, I have to multiply, okay, this distance, this is d2. Okay, the reason why is the line of action of the force F is here. This is the line of action, the horizontal one. So the perpendicular distance from the line of action to the pivot, okay, is d2. So therefore, you have F times d2 plus the weight of the truck will also give rise to a clockwise moment. So line of action of the force is here. Okay, so the perpendicular distance is somewhere here, d3. Can? So plus W times d3. Then you make F the subject and you'll be able to get an expression of F, the force F. Can? Okay, next. For this question, it is pretty straightforward. It's just a simple moment question. Let's see, did I put any tricks here? Okay. The trick here is that I go and put total moment. Okay, so because of this word total moment, therefore actually you do not really need to do any calculation, because you see this 100 Newton about this pivot will give rise to a clockwise moment. Then this 100 Newton on the right of the pivot will give rise to a counterclockwise moment. So basically the moment caused by this force and the moment caused by this force will eventually cancel out. So the total moment will be 0 Newton meter. Okay, for those of you who cannot conceptually solve this question, you can do your own calculation.